Final speaker in this webinar. So our annals paper highlights, that's Gustavo Ferreira da Silva. Forgive me for tripping over your name there, from Sao Paulo State University in Brazil. Gustavo, could you share your screen, please?
Yes, of course. Okay, thank you. Hi everyone, it's a great pleasure attending this webinar to talk more about my last published art paper with the title Sugarcane Nutrition and the Organomineral Fertilizer, Phosphate-solubilizing Bacteria, and Reduced Phosphate Doses, published by Applied Animal Biologist. I am Gustavo Ferreira da Silva. I am bioprocess and biotechnology engineer from São Paulo, Brazil. This paper is one little step towards sustainable agriculture, and in the context that sugarcane is one of the most important crops for energy transition in Brazil and in the world. Brazil is the biggest producer of sugarcane and use the cultivation for produce sugar, but also produce first and second generation ethanol, specifically for energy transition. But for sugarcane cultivation, phosphorus fertilization is a big challenge, mainly in tropical soils in Brazil. This challenge is because phosphorus has a specifically dynamic in the soil, and the amount of fertilization can be retained in soil, which impacts on productivity, cost, and environment issues. Our paper have a goal to stabilize and provides more information about a different agricultural practice with phosphate-solubilizing bacteria and organomineral fertilizer as a new biostrategies to overcome these challenges with phosphorus fertilization. Talk more about the sugarcane experiment. We did an experiment in a greenhouse structure with a phosphate-solubilized bacteria strain, Bacillus veracensis UFB3918, with organomineral fertilizer based on humic substance, and a phosphorus fertilizer, specifically monoammonium phosphate, a high-soluble phosphorus fertilizer. The experiment was conducted with 8 treatments. The first was a control with the recommended dose for MAP. The second, only organomineral fertilizer without application of phosphorus, and 2 groups of treatments. The first group, only organomineral fertilizer with different dose of phosphorus, 130, 230, and 330. And the second group of treatments includes Bacillus veracensis with organomineral fertilizers and the 3 different doses of phosphorus. The main goal here is to understand how the reduced doses impact on phosphorus nutrition, overnutrition of sugarcane, root territory, and nutrient uptake. This work focused on a different agriculture practice, and so established a new technology for sugarcane cultivation. I will highlight some results, mainly here focus on phosphorus on soil. If we see the treatments with organomineral fertilizer, we can see that the treatments with reduced dose, 130 or 230 of phosphorus, provides a comparable phosphorus on soil than culture with recommended dose. It happened because humic substance is recognized as a product with slow release of nutrients, phosphorus includes, and can help reduce the visibility and of phosphorus on soil, and so reduce the loss of phosphorus on soil. Now focus on treatments with Bacillus veracensis, the phosphate-solubilizing bacteria. We have great results here because the first treatment with Bacillus veracensis, organomineral fertilizer, and 130 of phosphorus doses, we have the comparable phosphorus on soil too, but I will highlight the other two treatments, 230 and 330 of MET. Here, we have an improvement of phosphorus on soil of 39%. It's happened because phosphate-solubilizing bacteria has recognized it as a product, a biological product that can have high efficient in phosphorus uh, phosphorus solubilization because these bacteria can act in organic and inorganic phosphorus solubilization by diverse mechanisms as release proteins, release hydrophores, release a lot of molecules that can help the phosphorus solubilization. Talk more about other phosphorus parameters in sugarcane plant. Here I will focus on the treatments with bacteria and organomineral fertilizer. Here we can see that should phosphor content, phosphor use efficient, and phosphor accumulation was comparable to the control for the treatments with reduced doses of phosphorus. These results can show to us that we can reduce the fertilization without reduce the availability and without reduce the phosphor nutrition on sugar. Talk more about overall nutrition, not only focus on phosphorus. The technology that's apply bacteria and organomineral fertilizer with reduced doses 130 and 230 not affect the overall plant nutrition negatively. On the contrary, we have gains in some nutritional parameters for nitrogen, potassium, iron, zinc, and copper. Talk more about roots. This table shows the root trajectory for sugarcane. We don't have bad results here. On contrary, we have in treatments with bacteria a slow reduction of root length, but it's not prejudiced and negatively affected the sugarcane. On the contrary, uh, we see that the reduction in root length is because we have more phosphorus, uh, more availability of phosphorus, and so the plant reduce the root length because it's not necessary archive deep structures on soil to archive more phosphorus. Talking about nutrient uptake by roots, uh, on the treatments with bacteria, organomineral fertilizer, and reduced dose, we don't have negative effect on nutrient uptake for all the nutrients screening for the sugarcane. On the contrary, as I said in last slide, the nutrient uptake for copper was higher than copper. Yes, to the end, I will highlight some take-home messages from this article. Our paper established that the use of phosphate-solubilizing with V3918 phosphate-solubilizing bacteria strain already used in the agriculture practice in Brazil with the use of organomineral fertilizer based on humic substances can provide a 66% reduction in the dose of phosphate in sugarcane cultivation. Overall results show to us that this technology provides adequate supply of phosphorus and other nutrients. With that, provides a satisfactory overall nutrition of sugarcane with no impact in all nutrients. So it showed to us that we can reduce the fertilization of phosphorus, reduce costs, reduce environment issues, reduce these challenges with the use of this product, maintaining the phosphorus availability to sugarcane cultivation and plant development. So to finish, this technology established in our paper is a sustainable alternative to overcome phosphate fertilization challenges and acquire high productivity with less environmental and economic impact. I would like the co-authors that helped me in this experiment and this work, Ariane, Melina, and Marcelo, my supervisor. And thank you all for attention. Please see, read, and share my paper. I'm free for questions, and I will leave here my email and my LinkedIn profile for questions or further connections.